Okay, so we're going to continue with our limits using the properties of limits to evaluate limits both graphically and algebraically. So we're in part 2. All right, so we briefly looked at some graphs and the rules that go along with finding limits. The first rule is the constant rule, and it says the limit as x approaches c of k equals k. All right, in English we just say the limit of a constant is the constant. The identity rule, I have a picture of that down here. Okay, thinking back to that graph, the identity rule is really you're taking the limit of y equals x, that function. So as x approaches c on that function, y is equal to c. The limit is c. So we say the limit as x approaches c of x is c. That one's really not very different in English. But the rest of them, the coefficient rule, if you have a function times a coefficient, all right, we say the limit of a constant times a function is the constant times the limit of the function. The sum rule, if you have two functions added together, the limit of a sum is the sum of the limits. The difference rule, the limit of a difference is the difference of the limits. The product rule, the limit of the product is the product of the limits. Okay, the quotient rule, the limit of a quotient is the quotient of the limits. So that's as long as the limit of g of x, the denominator, is not 0. And the last one, the power rule. The limit of a function raised to a power is the same as the limit of the function raised to the power. Okay. So the number L we're going to use as the limit of a function of f of x as x approaches c. Here's the notation we're going to use. So it's the limit of the function f of x as x approaches c is that y value L. Okay? We care about x getting arbitrarily close to c, but we don't care about x being equal to c. Okay. In order for a limit to exist, we must have the same number L as we approach x from either the left or the right side. Okay? So we talk about that as the left-hand limit and the right-hand limit. We use the notation x approaches c with a little negative sign, almost like its exponent, saying we're approaching c from the left. So graphically, what we're talking about is if here is c and here is some function, as we approach c from the left, right, as x gets close to c from the left, what's happening on our graph? Well, our y value is getting close to this y value. And as we approach from the right, our graph is doing the same thing. It's getting close to this same y value, whatever it is. Okay? Here would be an example where maybe it's not the same. So we might have a function, a piecewise function. Okay, that looks like this. So there's a jump in our graph. So this time, the limit from the left approaches whatever y value this is. Okay? But the limit on the right, as we approach, if this is where c is, right? As we approach c, well, it's this y value. Okay, those two y values are not the same, obviously, so this limit does not exist. Okay, let's take a look. All right, and so that notation, let's make sure you know the notation. The limit as x approaches c from the left of f of x, and the limit as x approaches c from the right would have a little positive sign on it. Okay. All right, so remember, if the left-hand limit, that's my abbreviation, left-hand limit equals the right-hand limit, then the limit exists. All right, so let's take a look at this graph, example number 1. So this is called the step function. Its real name is the greatest integer function. All right, and the notation for that is here, but I'm going to write it a little bit larger. G of x is equal to, and we've got actually these square brackets around x. Oftentimes you see it with this double barred square bracket. All right, that stands for greatest integer. Okay, so here we go. The limit of the greatest integer of x as x approaches 0.6. Okay, well 0.6 is somewhere in here, and the y value there, as you approach from the left or the right, is 0. Okay, this next one, the limit of the greatest integer of x as x approaches negative 2.9. Okay, negative 2.9 somewhere out here. Looking at my graph, looks like my y value is negative 3. Okay, so if you haven't seen the greatest integer function before, it is the greatest integer less than or equal to the number you put in. So when I put in 0.6, the greatest integer less than or equal to 0.6 is 0. When I put in negative 2.9, the greatest integer less than or equal to negative 2.9 is negative 3. Okay, let's look at number 3. Number 3, 4, and 5 go together. Okay, we are approaching 2 in all of these, but here we're approaching 2 from the left. So let's take a look. As I approach 2, so I want to know what's happening when I get close to x equals 2 from the left. There we go. So from the left, as I get close to 2, it looks like I am at the value of 1. All right, so here there is an open circle. So the y value when x equals 2 is not 1. It's actually up here at 2, right? What's the greatest integer less than or equal to 2? 2. Okay, but as I approach from the left, I've got to travel along this piece of the curve. So I'm traveling along, and what am I getting close to as I get close to 2 in terms of y value? I'm getting close to 1. I'm still at 1. Okay, on the right-hand side, this is number 4. As we approach 2 from the right-hand side, okay, my y value is at 2. Okay, so as you approach from the left, you're approaching 1. As you approach from the right, your y value is 2. These two values are not the same. The left-hand limit and the right-hand limit are different. So what is the limit as x approaches 2? Now you're looking really from both sides, from the left and the right. Well, they're not the same. So we like to write an abbreviation, DNE, does not exist. Okay. All right, let's take a look at the next graph, example number 2 for these next 5 problems. What is the limit as x approaches 3 on this function? All right, well, here's x equals 3. It appears that my y value when x is 3 is -1. And as I approach from the right and from the left, I'm approaching that same y value. The y value is -1. Okay, what happens as x approaches 2 on the function? Okay, well, first let's look, what is the y value on the function at 2? 2, f of 2 is actually 2, 0. Okay, so it's this point right here. But I'm going to change my color here for just a sec. But when I travel along the curve on the right-hand side, I approach a y value of -2. And when I approach x equals 2 from the left-hand side, I also get -2. So this y value that I approach is -2, even though the function value is 0. Okay, so remember, I don't care what happens when I get to the point x equals 2. I care what I'm getting close to. All right, let's look at the limit of f of x as x approaches 0 from the left. Okay, from the left, traveling along the curve, it looks like I approach 1. Okay, from the right, as I travel along the curve, it looks like I approach 0. So we're going to say that the limit on the left and the limit on the right are not the same, and therefore the limit as x approaches 0 does not exist. Okay. All right. These next 4 questions are asking us to use the properties of limits. Okay, so you might refer back to that list if you have it handy. All right, first of all, we have 2 functions here. We have this f of x function. Kind of looks like a roller coaster, except there's a hole in the graph and another value point here at -2, 2. And then g of x is the linear, piecewise linear. This negative sloped line up to 1, x equals 1, and then this positive sloped line greater than 1. Okay, so here we have the limit as x approaches -2 of f of x plus 5 times g of x. Using the limit rules, what is the limit of a sum? It's the same as the sum of the limits. Okay, and I should really have down here x approaches 2. All right, but then here we have the limit of a constant times a function. All right, well, that's going to turn into the limit, 5 times the limit of the function. All right, and I'm still going to have the limit of f of x out here. Okay, so only because I've run out of room, I haven't written x approaches 2 below these, but I should have that there. So it should say the limit of f of x as x approaches 2 plus 5 times the limit of g of x as x approaches 2. Okay, well, let's look. What is the limit of f of x as x approaches 2? Here's 2 on my function. Oh, I apologize. That's a -2, so let me come over here to -2. That'll be better. -2. So it looks like the limit from the left and the limit from the right is 1. Even though there's a hole there, that doesn't matter. It's what I'm getting close to. Then I have plus 5 times, what's the limit of g of x as x approaches -2? Okay, from the left and from the right, we're approaching -1. All right, so I have 1 plus -5 or -4. Okay, I'm going to run out of time here, so I'm going to stop, try these other problems, and we'll come back and meet again.